Hello everyone, welcome to the numerical methods class. In this class, our topic is chapter 12, curve fitting actually. But in the curve fitting, first we will learn about the simple statistics required for the regression. Regression is the way of having the curve fitting. And for that we need some simple statistics because we will be dealing with some data. And for the data we have some statistical parameters that we need to calculate. Let's learn about them first in this chapter 12. Then we will continue to the regression for curve fitting. In this slide, we will check the simple statistical parameters which are required for the regression. First of all, arithmetic mean means the average actually of the data, and basically we just sum the data points and all of them and divide it by the number of the points. Basically, summation of the y data, I is the number of data from 1 to n is the number of data, and we divide it by n to get the mean of the data. Another statistical parameter is standard deviation shown by Sy, and this is a measure of spread for a sample in data. Basically, it shows how large or narrow the distribution of the data compared to the mean value. And we calculated by this formulation. St is total sum of squares of the residuals between the data points and the mean. So we will have the mean first. Then for each data, we will subtract the mean from the data and take the square of them, as you can see here, and sum all of them as this value. Then we will divide it by n minus 1. And n minus 1, actually n is the number of data. There is a subtraction of 1 from that. And if a sample spreads out widely around the mean, St is very large. So if the difference here is large, that means the standard deviation is large. That means the sample spreads out widely around the mean. And if the samples are grouped tightly, so they are very close to each other, then this is very small, which means standard deviation is small. So these statements are talking about those. And there is also variance. Variance is the square of the Sy or standard deviation, or the opposite is true as well. The standard deviation is just root square of variance. So this is another measure of spread. And here, this is the formulation. Basically, we have just the square of this, giving us this divided by n minus 1. But so these two can be used, but the difference is that the standard deviation is in the unit of the mean or the data, but variance is the square of that unit. So to be able to make a fair comparison with the mean or the data values, standard deviation is more convenient because it has the same unit. But variance has the square of the unit, so it may not be a very fair comparison to understand the deviation of the data. So here n minus 1, as here as well, represents the degrees of freedom, and it is actually n minus 1 because one value is fixed and the rest is freely determined. Also, the reason of using minus 1 here is that there is no spread of a single data point. So if we have only one data and want to have a standard deviation or variance, if we say n, that there will be a spread between the mean and y, but because for one data we will not have a spread or the distribution or deviation, we try to make this an infinity by having minus 1. 1 minus 1 becomes 0, which makes this not defined. So that's why it's preferred to use n minus 1 instead of n. Another formulation of variance, and a more convenient formula to be able to have the calculations efficiently, is this. In this is somehow different, but it is about the same. Only difference is that instead of having the square after the parentheses or after subtraction, we have the squares of the data and sum them. Then also we have the sum of the data and square of it divided by n, and it's divided by n minus 1. So these two will give the same result. You can check that. But the calculations are more efficient here. It doesn't require pre-computation of the mean value actually. Here you don't need to calculate mean, but here you can see it's similar to mean, so you make this calculation. and yields the same result as the previous equation. So you can use either of these to have the same results. There is also coefficient of variation. It is shortened by CV. This is basically the ratio of the standard deviation to the mean. So you calculate this and divide this by this one. It's basically kind of an error metric. And we also multiply it by the percentage, 100, to be able to have a normalized measure of the spread. It has a similar spirit to the percentage relative error. We learned about this, error divided by true value. So this is the error, this is the true value we can think of. The standard deviation divided by the mean. Coefficient of variation. And 100% that means it's very good. But the change from it in terms of percentage will show us a variation coefficient. In this slide, we will have an example 12.1, for simple statistical parameter calculations for an example data. You can see here we have 24 data from 6395 to 6775, and it is ordered from minimum to maximum. But in regular measurements or other stuff, you will not have this ordered data. You can have a different order of these, but you can order them from minimum to maximum as well. But you don't have to have these simple statistics. So now we are going to learn how to use the simple statistics. Let's start with the mean value. The mean value of this is calculated by, let's write mean. The formulation was, if you remember, the summation of all data, yi, divided by the number of data. And the summation of all data, basically you sum all of these, and the summation is here 158.4, and divided by n, and the number of data is 24 here. When we have this, the mean is 6.6. So you can see actually the mean is between 6.775 and 6.395, around here, 6.6. Let's calculate the standard deviation. For standard deviation, we have the formulation of Sy is equivalent to root square St divided by n minus 1. And if you remember, St was the summation of the subtraction of the data from the mean value and the square of these. So we will simply subtract all the mean, actually 6.6, from all data. Here, for instance, minus 6.6, minus 6.6, minus 6.6, and it will give us the subtractions. Then we will take the squares of these, like this, to the end. Then we will sum them at the bottom, over here. If we do this, you will get the results, as you can see here, these results. Let me erase this too, so that you can see easily. So these are the results. To use in the standard deviation. Basically, the summation of these is here at the bottom. You can see. Then this is actually 0.217. Let's put it here and divide by 24 minus 1. In this scenario, Sy is, and take the root square of it, then Sy becomes 0.09 7133. So you can see that the deviation is too small actually compared to the mean data, 6.6. We can also calculate the variance. Basically, the variance is the square of this standard deviation. So Sy square is equivalent to 0.097133 square, which is 0.009435. So if the standard deviation is less than 1, taking the square becomes much smaller. And that's why the variance might be misleading about the variation, because it seems very, very small. But actually with the standard deviation we have the same unit with mean, so this can give us a better judgment of the deviation of the data or the spread of the data. But still variance is useful as well. That's why we need to learn how to calculate it. This is one way, just take the square of the standard deviation. Another way, we said that we can use this formulation for sy square, total yi, the square of all yi's and sum them, minus sum all yi's, then take the square and divide by n and n minus 1. If we take the square and sum them all, we actually take the square each of these, then sum it. That gives us 1045.657 minus the summation of all data here, 158.4, and its square. Divide by 24, divided by 24 minus 1, meaning 23. Then from here as well, we will have the same result. It is 0.009, 0.009 and you can see that these are the same. They should be the same because we find the same thing. Finally, we will calculate the coefficient of variation. And we calculate it by CV is equivalent to the standard deviation SY divided by the mean Y. And SY was 0.097133 and the mean was 6.6. Of course, let's multiply by 100 to have a percentage of it. It gives us the value of 147%. So there is about 1.5% variation in the data. It can tell this to us. So these are the basic statistical parameters that we should know about finding the statistics of the data.